Moving on then from loops, we're going to look at classes and objects. Swift is what's known as an object-oriented language, which means it's built around classes and objects. So it's important to understand what they are and how they work. And the idea is actually pretty simple. I think it's best explained through computer games. So let's say we've got a computer game that has some ghost characters in it, and we need to be able to create several ghosts and destroy them as the player kills them, if you can indeed kill a ghost. So then the class becomes the general description of the ghost, and the object is a particular instance or example of it. All right, let's see what I mean. So I can create a class, just two S's, called Ghost, and the convention for classes is that they begin with a capital G. Unlike variables or arrays, we begin classes with a capital letter. So when I create my class Ghost, inside this class I can create various variables and functions. Although a function in a class is normally known as a method. So methods and functions are pretty much exactly the same thing, but we usually will use the word method when we're working in an object-oriented language. So this ghost might have various attributes. So for example, we might have a variable called isAlive, and that might be by default true. We might also have a variable called strength, and we might want to have ghosts of various strength. The default value for strength for a ghost might be, for example, 9. Then we could create a new ghost using variable, and then what we'd normally use is ghost with a small g to represent a particular object of the ghost class. And to make it clear that this is a ghost, we'd define it like that. So ghost with a pair of parentheses after it to say this is going to be a new object from the ghost class. And then we can do things like print ghost dot is alive. So we can tell whether our ghost is alive or not by getting that particular value. So we haven't changed anything, so the ghost is his default value, which is true. Then maybe we want to take this particular ghost and set their strength to 20. So maybe this is a particularly strong ghost. Then if we printed ghost.strength, we get our new value of 20. So hopefully this is starting to make sense, and you can see why, particularly in gaming programming, we might want to have these classes for types of things and then create and customize them as we need them. We can also put methods into our classes. So for example, we might want to define a method, and we can do that using func, which is a little confusing. We create a method using the keyword func, which is obviously short for function, but just shows you how similar functions and methods are. And I'm going to create a function called kill, which allows us to kill the ghost. And that will simply set isAlive to be false. And then we can apply that function to our particular ghost. So we can use ghost.kill, and then we can print ghost.isAlive just to check and see what's happened. And now you can see that we've got a false value for ghost.isAlive because we've run the kill method. One extra thing I'd like to show you is that we can even run functions that return a value. So let's say we wanted a method called isStrong, which is true if the strength of our ghost is greater than 10. Then we can create our method using func, and we'll call it isStrong. Notice we start with the lowercase I because this is a method, not a class. And then pair of parentheses. And this time we're going to use an arrow created by a dash and a greater than sign and bool. And that symbolizes that this method is going to return a Boolean. So all it does is check to see if strength is greater than 10, return true, else return false. So now we can use print ghost.isStrong, and for our particular ghost we should get, as you could just about see at the bottom before it decided to run it again, we get a true. There we go. So that's quite simply how object-oriented programming works. We create a class which has various variables and methods in it, and then we can create a new object which is a particular example or instance of that class, and then we can use all the variables and methods within that and apply them to our object. Now it might look like we could do this a lot easier without using classes, and at this scale that's true, yes we could, but when you're writing big programs or indeed a large code base that is maintained by lots of people, it's much easier if it's organized in this way and we can clearly see what's going on with each of the lines of code. So it will make your code much more maintainable and give it a much better structure if you use classes and objects. All right, so we're nearly at the end of this section now. There is one more thing I want to show you, and this is a topic that comes up a lot in Swift development, and that is the topic of optionals. And we're going to master that in the next video.